Hello my dear students, I hope you all are good. I am B S Pandey, your physics lecturer. My dear student, till now we have studied in this particular chapter, that is the laws of motion, about the pseudo force. In last class we have discussed how to see the pseudo force on any body. What should be the magnitude of pseudo force and what will be the direction of pseudo force act. Okay, today we will solve few questions of pseudo force. Even after solving this 5 or 6 questions based on pseudo force, I hope my dear students you will be able to solve any type of question of any level which will be based on pseudo force. Okay, so let's start today's lecture. We are in lecture number 32 of Newton laws of motion. Okay, and we are studying the concept of pseudo force. My dear student, let me first recall the concept of pseudo force. If it is a frame, it is moving with some acceleration, suppose a naught. Okay, so any body which is kept inside this frame will experience a force. If its mass is m, then it will experience a force in this direction opposite to the acceleration of the frame with the same acceleration of force. That force is called the pseudo force, and resulting this body will fly or like this way. What should be the magnitude of pseudo force that we have studied in last lecture? It was mass into acceleration of the frame. Mass of which? Mass of body and acceleration of frame. And what should be the direction? If it is the x-axis, my dear students, so the direction will be minus I cap. The direction of pseudo force should be opposite to the direction of acceleration of the frame in which body is kept. Okay, we have also studied, my dear students, that we cannot apply the Newton's laws of motion in inertial frame. We have, non-inertial frame. We have studied the two types of frame. Then after we just introduce the concept of pseudo force, inertial and non-inertial frame, we have studied that all the Newton 3 laws, that is the Newton first and second and third law, are applicable in inertial frame of reference. What does it mean by the inertial frame of reference? So the inertial frame of reference are those frames which have no any acceleration. Okay, that is the velocity either constant or acceleration is 0. This frame are called inertial frame or non-accelerating frame. Newton first and second law are strictly applied to this frame only, but Newton third law can be applied in both the frame of reference, that is inertial and non-inertial. Okay, now we will solve few questions on the basis of this pseudo force. Okay, my dear students, so let's start today's first question. This was the concept. Now the question. Few of the question I have been solved. Okay, I had solved without using this particular word pseudo force. I will give you in SC some questions are given, and that question I have given you the concept to solve without applying the concept of pseudo force. This is a platform, you can say an elevator. This elevator is moving up. Okay, this is elevator and it is moving up with an acceleration 3 meter per second square. I am giving you the value 3 meter per second square. A wedge is kept inside the elevator. A wedge is kept at of inclination, suppose it is 37 degree. It is kept inside the elevator. A mass is kept over. A mass is kept of m. Here the m is 10 kg, suppose. Okay, m is 10 kg. Now you have to find the acceleration. Suppose if this lift is not moving, my dear student, if this lift is not moving, then this block will slide down. Of course it will slide down. Now if lift is moving in upward direction with an acceleration 3 meter per second square, then you have been asked to find the acceleration of this block. You have to find the acceleration of this block. Let this value as a naught. You have to find acceleration of this block. What we have to find? Find acceleration of block. Thus we have to find. Okay. Now how we'll solve? Look at here carefully. In which direction this frame is moving? Whether this one is the inertial, non-inertial frame. Of course, you will find this is the non-inertial frame. Why? It is accelerating with some acceleration. So this is the non-accelerating. If any observer goes inside this lift, okay, this observer will find, yes, I am moving up. It means I am in an accelerating frame. If I am in accelerating frame, then all the bodies will kept inside this frame. It will experience pseudo force. Okay, so if this frame is moving up, there will be a pseudo force in downward direction. How much? It will act. It is mass times acceleration, ma naught. Let me draw the diagram over here. This is the mass. One, it is the mg. This is the angle theta. Suppose one weight of the body will act downward. Since this elevator is moving up, a pseudo force will act down. It is how much? Ma naught. Am I right? Now, no more concept you have to use, my dear students. Okay, your problem is solved now. Now you have to do the free body diagram and breaking of the component of force, and then you will be able to find the answer. Okay, what we used to do, we used to make the plus sign. Now here the two forces are acting in downward direction. That is the ma naught is also acting here. Ma naught I can write over here. Ma naught. How much angle? It is theta, made by the vertical axis. Okay. Now my dear students, we can write in this direction, and in this direction the component. In this direction the component will be mg plus ma naught sine theta, and here mg plus ma naught cos theta. Okay, is there any force in backward direction also? No. So this force is bringing the block in downward direction. So what we will write? With which acceleration it is moving down? We have consider it is moving down with an acceleration a. So we will write the net force is mg plus ma naught sine theta is equals to ma naught. Okay, m will be cancelled out. A naught, what we have to find actually? So sorry, this is the a now. So a will be equals to g plus a naught sine theta. This is the acceleration that you have to find. Value of g, it is 10. A naught, it is given 3. So it is 13. Sine 37, it is 3 by 5. Okay. After calculation, you can have the answer. So in this way, my dear students, we used to obtain. Okay. Now, on the basis of this particular concept, I'm going to give you another question. Okay. So, I'm going to give you the next question, my dear student. Look at here. Very slight I will change in the same question that we have solved right now. This is the elevator which is moving up with an acceleration 3 meter per second square, the same case. Okay, it is moving up with an acceleration 3 meter. Theta, it is 37 degree again. Now the two blocks are kept. If you got the concept how to solve this question, then you can solve this one also. Okay, now you are having the two blocks M and 2M. You have to find acceleration, okay, of this system. Like this is A naught, right? This is A naught. You have to find acceleration of system and tension in string. Acceleration of system and tension in string. Okay, this is your homework. M is 10 kg. Okay, you have to solve. Alright, yes. Here the two blocks are kept tied with the string. You have to find tension in that string, and also you have to calculate acceleration with which it will move down, that the system will move down. Now next question. The same case, this is the elevator, but in this elevator from ceiling a pulley is tied, a pulley is suspended, and two blocks are suspended with massless string, okay, in this way. Now this system is going up with an acceleration g by 4 meter per second square. This is the mass m, this is 2m. If m is 10 kg, find force on ceiling. Okay, we have to find force on ceiling. What will be the force on ceiling? Okay, this is our question, how to solve. Again, you can see, my dear students, this entire lift, that is the system, is working as non-inertial frame for any observer which is standing inside the lift. Am I right? Yes, inside the lift, if any observer is standing, then this is non-inertial frame. So if this entire system moving up, there will be pseudo force on both the block in downward direction. Am I right? How much force? On this block the force will be m a naught, and for this block the force will be 2m a naught. Now after applying this pseudo force, okay, pseudo force, the system become in inertial frame. Now you can solve this question. Take the free body diagrams. This is the tension T, same string, tension remains same. Here the mg, here the twice mg. Suppose here T naught. Okay, for ceiling, for pulley, what we can write? We can write T naught equals to T. So the answer of this question, that we have to find force on ceiling will be how much? It is T naught, and T naught it is equals to how much? To T. So using some calculation we have to find only the value of T. We are going to write the equation for this one. After acting these forces, this system is not stopped. The blocks are not stopped. Blocks are moving up and down. If it is moving down with an acceleration a, it is moving up with an acceleration a, suppose, then we can write the equation. If it is moving down, then 2mg for this block, for 2m, we can write 2mg Is there any other forces which is acting downward? Yes. This is the another force which is acting downward. It is twice MA naught. So plus twice MA naught minus. Is there any force in upward direction? Yes, it is tension T is equals to how much? It is twice MA. Am I right? Yes. This is the equation 1. Now for this body, if it is moving up, so which force is responsible to take this body in upward direction? T. So T minus in downward direction there are two forces. It is MA naught minus MG is equals to MA. Am I right? Kindly sum of these two equations, you will find the value of T as well as A. But here from this two addition you will get the acceleration. This is cancel out. Here mg plus ma naught is equals to thrice ma. M will be cancel out. So A will be equals to how much? You can see it is g plus a naught divided by 3. Divided by 3. G plus a naught divided by 3. If you got the value of A by putting all the values, G is equals to 10, A equals to 3 divided by 3, then you can find the value of A. Putting the value of A in equation 1 or 2, you will be able to find the tension T. Am I right? Yes. So you can find out the value of T and multiplying with 2, that will be the net force acting on the ceiling. And this was asked in the question. Okay, my dear students? Yes. Now, next question. In next question, this is not a very tough question, but I'm going to just change a little bit. So here the fourth question, my dear students. Suppose this is a trolley and this trolley is moving with some acceleration due to application of force. Here I am applying a force, okay? But two blocks are kept. One here, suppose M1, and another block here, suppose it is M2. What will happen, my dear students, if this trolley is not moving? If this trolley is not moving if there is no force acting and trolley is not moving, trolley is static, then what will happen? If M2 is acting over here, there is no friction, so it will move down and it will move forward. Here in this question, you have been asked what should be the force, minimum force applied from here on the trolley so that those two blocks does not slides. Okay. For what value of F, M1 and M2 does not slide. Okay. What should be the value of force so that M1, M2 does not slide? Okay. Here, if you will apply a force, of course, there will be pseudo force. Try to find the direction of pseudo force. On this block, the pseudo force will be in this direction. How much? It is MA naught. Okay. And over this block, there will be the force. It is how much? It is M2 A naught. Am I right? Yes, it will act. Due to that pseudo force, if someone is acting force in this direction, might be it will not move. It will not slide. Okay. So this is our question. But we have to find what should be the force so that these two blocks should not move. My dear students, suppose due to the application of this force, this frame attain an acceleration a0. Okay, that's why we are given here the pseudo force ma0, ma0. So it attain an acceleration a0. What should be the force successfully F if these two are in a static state? So if these two are in a static state, so combined system having the mass, how much? Oh, here mass I have not given. For this trolley, the mass is given in the question. It is m. Okay. Now, what will be the force? So we will write the force is equals to, I'm going to solve. The force equals to mass times acceleration. So what will be the mass of the entire system? My dear students, the mass of the entire system, it will be the m plus m1 plus m2, and acceleration, it is a0, and this will be our answer. But our aim is to find the acceleration. Our aim is to find the acceleration. How to find this? a0. Okay, so for a0 we are going to do the calculation. My dear students, for a0, look at here, this is very simple. The concept of pseudo force here only to apply in which direction you have to apply the pseudo force. This one is not. Okay, this one is much. Now we can see here the tension will act T, and here the tension will act T. Okay, if these two are not moving, of course, if these two are not moving, it means the force in forward direction and backward direction will be equal. Here the force in downward direction, upward direction will be equal. Which one is acting in downward direction? Here m2g, and it will be equals to, for m2, we are going to calculate this. For m2 we can write m2g is equals to T. Am I right? Yes. Why I have written? Remember, this is not moving down. You cannot write m2g minus T equals to m2a because it is not moving down. According to the question, this one is a condition. What should be the force so that it does not slide? If it does not slide, it means acceleration is 0. Okay. Now for m1, what we can write, if it is not sliding, then T will be equals to m1 a0. Am I right? Yes. Now from this two equation, this one and this one, you can see m2g is equals to m1 a0. Okay, so you can write a0 is equals to m2 by m1 into g. Successfully we got the value of a0, and here we were trying to find out the value of a0. So if we got the value of a0, kindly put the a0 in this equation, then you will have the force. It is as m plus m1 plus m2 into m2 by m1 into g. This is the answer. Okay, so in this way you have to approach the questions of pseudo force, and you have to apply the concept to find the answer. Okay, my dear students, now let me discuss another question which is based on the pseudo force. So in this next question, my dear student, we are going to solve the question of inclined plane, that is the wedge. Okay, we will place the body over the wedge. Do you remember the acceleration of any block, my dear student? Over the base, the acceleration is g sine theta. Okay, over the base the acceleration will be g sine theta. But here, in case of pseudo force, we will get the result, and you have to remember. Okay, suppose this is angle theta, a block is kept here, and we have to apply a force F. If this vase in a static state, remember, if this vase is in a static state, what will happen? This block will slide down. So we are giving here the force and this vase is moving forward, so that it will experience a pseudo force in backward direction, and we have to find the force F applied on the vase so that this block does not slide over this vase. Okay, the mass, suppose it is M, and the mass of the vase, suppose it is capital M. What we have to find? We have to find the force F so that, okay, so that block does not slide. Does not slides. Okay, my dear student, if this block is not sliding, remember, if it is in a static state, then F must be written as, again, if you can solve the question, you can solve. Suppose due to the force, this entire system moves with an acceleration a0. So what we can write here, the F is equals to m plus m times a0. Now again our aim is to find the acceleration a0. Okay, our aim is to find the acceleration a0. But it is quite obvious, if this frame is moving with an acceleration a0, it will experience a pseudo force in this direction, and it is ma0. Am I right? Yes. Now we are going to draw the free body diagram. In this direction, this is mg, this is angle theta. Okay, so this will be mg sin theta, and this is mg cos theta. But we don't have to solve for the normal. If this question will be asked in friction chapter, then we will study the normal. I am leaving that normal. Otherwise, this concept, this component will be the mg cos theta, and it will be equals to the normal. Now, look at here carefully. This is ma0, and this ma0 making an angle theta over here. Look at carefully. It is theta. Am I right? If this is theta, this would be the theta. It means this will have the two components. One along this one, it is ma0 cos theta, and another along this one, it is ma0 sin theta. No more forces are acting, my dear students. The two forces are acting. If this block is in rest with respect to the wedge due to the application of force, remember, the entire system it is moving, but over the wedge this will be in a static state. And then we can write what we can write. This force must be equals to this force, okay, to be in equilibrium. So the for block M to be in rest, ma0 cos theta should be equals to mg sin theta, will be cancelled out, and a0 it is g sin theta by cos theta, that is g tan theta. Remember, this is the acceleration due to pseudo force. So here in this case, if there will be the pseudo force, the acceleration over the inclined plane will be g tan theta. Remember, this is the very, very important result. As you have remember, g sin theta, if any body is sliding down, g sin theta. So in case of pseudo force, the acceleration will be g tan theta. Okay. Now, what we have to find? The minimum force due to which it is not sliding. So to not slide, we have, for not sliding, for no sliding, we got the condition. What should be the acceleration? It is the g tan theta. And if the entire system, it is the g tan theta acceleration, it is the g tan theta. Of course, we got the a0 g tan theta. So the force will be, we will put the value of g tan theta, that is the a0, in this equation. F will be m plus m into a0, which is g tan theta. This is our answer. I hope you understand. Whether it was very difficult, my dear students? No, this was very easy. Okay, even you can solve. Okay, one more question. Should we study or should I give homework? Okay, I'm giving you homework, my dear students. One question I'm giving homework, and I am giving that question of the very good level of SC Verma. Try to solve that question. I'll give you the hint of that question also. Okay. Let me wrap this one first. I'm giving you a question of SC Verma, and I hope you can solve that question by yourself. If you will think very wisely all the things I'm going to give you as a hint, then you can solve this question. This is the wedge on which a block is kept. Mass of the wedge is m dash, mass of the block it is m, and this wedge is tied with a string. Okay, this wedge is tied with a string, goes over a pulley. Okay, and this is the ground. With the ground, remember, this pulley is attached. Its mass is m. Of course, if this mass is sufficient, it will move down and the system will move forward. Okay, so these values are given. Now the question, for what value of m this m, for what value of m block m, this one does not slide on wedge. Okay, for what value of m, what should be the value of m so that it does not slide? My dear students, you have to solve this question. This is your homework. Okay, I'm giving you the concept. Okay, I'm going to give you the hint. Remember, my dear students, for this block to not slide over this wedge, what should be the condition? What should be the acceleration? We know very well. Okay, it is the g tan theta. Of course, this entire system should be moved with g tan theta. What are the masses? Doesn't matter. G tan theta. Okay, the angle matters. So here angle it is, suppose theta. Okay, so g tan theta is the should be the acceleration. Of course, this wedge should be moved with an acceleration g tan theta. It means this should be also moved downward with which acceleration? G tan theta. Alright, if you have the acceleration of this one g tan theta, break the component here, make the free body diagram. Here the tension, here the tension. This tension will carry all this system in forward direction with which acceleration? G tan theta. And this block will move downward with which acceleration? It is g tan theta. If you apply these two equations, you will find the value of m. Okay, this much is your work. My dear students, try to solve this question. Don't leave it. Very important. Okay, my dear students, so this is all about the today's. We have discussed all the questions, all type of question which is based on the pseudo force. If you will get any other questions from any book, okay, from anywhere, RT need anywhere, okay, mains or advanced, then you must give me that question in the group. Okay, students, so this is all about today's lecture, my dear students. Thank you very much.